A centrifuge is another commonly used piece of laboratory equipment. It is often used to separate liquids from solids, or liquids with different densities, or for example for isolating cells suspended in a sample. The most common type of centrifuge encountered is the microcentrifuge that is used with 0.2 ml to 2 ml centrifuge tubes and spins at up to 13,000 revolutions per minute or RPM, and is used with most standard lab samples. However, larger centrifuges exist for use with samples of 15 ml or more. This is often used to process clinical samples like blood. Finally, ultracentrifuges are specialist equipment for centrifuging samples at very fast speeds, 30,000 RPM upwards, and are often used for separating ultracellular components like proteins. In this tutorial, we will go through how to use a centrifuge. Step 1. Prepare the centrifuge. Select the speed, often in RPM or G, and the time you require. Most centrifuges have a selection button for this. For example, if you are asked to centrifuge a sample at 13,000 G for 5 minutes, select the speed. You may also need to check different centrifuges to ensure the scale of the numbers is the same. Then select the time. If you require centrifugation for less than a minute, you may need to set your centrifuge for 1 minute and stop after the required time has elapsed, for example 30 seconds. Step 2. Load your samples. Once you have set the correct time and speed, you can load your samples. First, open the lid of the centrifuge. Next, remove the protective inner cover from the rotor of the centrifuge. Take a sample and position it in the rotor with the hinge of the sample towards the outside of the rotor. Now take another sample and position it on the outside of the rotor, again with hinges to the back. The rotor is now balanced. Centrifuges should only be operated when balanced, and each sample should also have a similar volume of liquid to aid in balancing. Bear in mind the tolerance on differing volumes decreases with increasing centrifuge speeds. If you need to add more samples, remember to add them in pairs that are opposite each other to ensure the machine is balanced. Step 3. Centrifuge your samples. First, put the protective lid back on the rotor. This stops the rotor from being damaged by debris should a sample leak or its container break. Close the lid of the centrifuge and press go. As the centrifuge increases in speed, check the centrifuge is not wobbling or making very loud noises, as this indicates that the centrifuge is unbalanced. If you suspect the machine is unbalanced, stop the centrifuge immediately and then check your samples are opposite each other with a similar volume to confirm the machine is balanced and adjust if needed. Do not walk away from your centrifuge whilst it is in use. Once the program has finished, remember to collect your samples. Brief centrifuge. Sometimes you'll be asked to briefly centrifuge a sample. To do this, simply load your sample without setting a time and speed. Put the protective cover on the rotor and shut the lid as normal. Rather than running a program, simply press and hold the pulse button for 4 to 5 seconds. This is all that is required to briefly centrifuge a sample. RPM and G and RCF. Some protocols will have speed quoted as RPM or revolutions per minute of the rotor in the centrifuge. However, you also often hear speed quoted as G or RCF. RCF stands for relative centrifugal force. It describes the amount of force in terms of acceleration applied to your sample. RCF is also the same as G because they are both related to the standard acceleration due to Earth's gravity. What should you do if your protocol gives you speed as the alternative unit RCF? Some centrifuges do have the capacity to have speed set as RCF. In other cases, you will have to convert RCF to RPM. This can easily be done by measuring the radius of the rotor you want to use and using a nomogram chart to convert to RPM. Step 1. Prepare your centrifuge by selecting the time and speed. Step 2. Load your samples into the centrifuge. Remember to balance similar volumes of liquid opposite each other. Step 3. Run the centrifuge program, but check for signs of unbalanced loads such as loud noises and wobbling.